Okay, let's start our class. Unit 7, last unit of this cellular technology syllabus. We completed the content of the unit 7, like space division, multiple access, and different types of multiple access, like frequency division, time division, and code division, multiple access. And apart from this, we have this hybrid spread spectrum technique, and also we have space division multiple access. Okay, SDMA. Okay, these are the things in this multiple access, and let's move on to the next topic. Packet radio protocol. This is very important in the wireless communication. Packet radio protocol. In this packet radio protocol, we have different types of protocols. Let's see from here in the Google. Okay, all those things are the common packet radio protocols. Okay. Okay, in this it not display about those aloha and all. First, let's see that's packet radio protocol in the image. Okay. Okay, there is no actual pictorial representations for this. Okay, let's move on to the slide. Okay, what is the packet radio protocol? There are mediums. Okay, we have a medium access protocol operate for packet radio network. So in this medium we have three types. One is aloha, second one is slotted aloha, and carrier sense multiple access CSMA, and also you can have here it doesn't display this one, carrier sense multiple access slash collision detections CSMA slash CD you can have also. Okay, this CSMA is subsectioned. We can see it in the next slide. First, let's see this this aloha. This is the protocol. Okay, aloha is the name of the protocol used in this radio communication or it's also implemented in the satellite communication also. This is the old technology used implemented in this in the radio communication, and also developed at the University of Hawaii. Okay, Aloha Net, also known as this Aloha system also, and we can simply call this Aloha. This is used for this computer network or satellite communication, and also pocket radio communication. And this Aloha Net became operational in June 1971, providing the first public demonstration of wireless packet data network. And this Aloha Net used a new method of media access, Aloha Random Access, and experimental ultra high frequency for its operation. So it's using this ultra high frequency. Let's see in this pictorial. Aloha sorry, Aloha protocol. Okay, let's see here in this peer Aloha. This is the first Aloha. Okay, so in each and every stations having a channel to transmit the signals, and here also we have a user A B C D E, and in these communications with the stations, then it's having some collisions during the time of the transmissions. Okay, in pure Aloha, frames are transmitted at completely arbitrary times. So it transmitted in the arbitrary times. So we are having a collisions in this pure Aloha. Let me explain a little bit about the pure Aloha. The version of the protocol that also known as the pure Aloha implemented in this Aloha Net was quite simple and also divided into 2 points. If we are having the data to send the data, that's all. If while you are transmitting data, you receive any data from other stations, that's one. While we are transmitting data, we receive any data from other stations. Okay, we can receive data from other stations. There has been a message collision, so it's having a collisions while transmitting, then we can receive from other stations. This not for our data, then the messages collide with each other. All transmitting stations need to try resending letters. If there are collisions in the time slot, in the particular times. Here also that's overlap, here is overlap, here there's some collision, here also is overlap here. Then all transmitting stations, all those transmitting stations will need to try resending later. This is the problem of this pure aloha. Okay, pure aloha. The step implies that in this pure aloha does not check whether the channel is busy before transmitting. So it does not care about the communication media, whether is there any transmission or not. Then it's simply transmitting these things. Since collisions can occur and data may have been sent again, Aloha cannot use 100% of the capacity of the communication channel. So it is not efficiently occupied the channels in these communication channels in pure aloha. And to assess in this pure aloha, for assessing this thing, we need to predict the throughput. The throughput is the maximum expected input. Okay, the maximum expected input. This is called the throughput. Throughput, the rate of transmission of frame. And let's have some assumptions in this assessment. All frame have the same length. So in pure aloha we have how to say, the box or any group of bits. Then we can say this is a frame. In this TCP communication also we have a packet like this. In this packet radio transmission protocol of pure aloha, its frame having the same length in the assumptions. Station cannot generate a frame while transmitting. While you transmit, you cannot generate a frame. Okay, you cannot generate the frame. And one point is that if a station keep trying to send a frame, it cannot be allowed to generate more frame to send. If one frame is sent, then it isn't allowed any frame to create the frame for next transmissions. Okay, these are the frame generations. The process of status attempt to transmit. Okay, the third one is that the population of the station attempt to transmit. Okay, attempt to transmit both new frame or old frame. Okay, and that collide according to the Poisson distributions. So there's lots of chance of collisions. Okay, according to this pure aloha, then if there are some collisions according to this, then this is the problem of this position distributions. Okay. Okay, these are the things in this pure aloha. And let's move to the slotted aloha. Is there any example here? Yes. Slotted aloha. Okay, in this slotted aloha, what improvements we have as compared to this pure aloha? An implement of the original aloha protocol. This is the pure aloha, which focus introduce the discrete time slot and increase the maximum throughput. So we have discrete time slot to send the packet by the stations or the users. Okay. Let me repeat that an improvement in this slotted aloha to the original aloha protocols, it's introduced discrete time slot and increase the maximum throughput. Stations can start transmissions only at the beginning of the time slot. Okay, if the time slot start, then it can start the communications, it can start the data transmissions, and thus collisions are reduced. In this, only transmission attempt within one frame times and not two consecutive frame times need to be considered, since collisions can only occur during its time slot. Okay, and during its time slot. So this is the advantages of the slotted aloha protocols. Then all those boxes, time slot, based on the time slot, all those boxes indicates the frames. Sad box, okay, if we are having the some two box in a single slot, then is called the collision frame. Okay. Now, set box indicate frames which are in the same slot. So if it's maintained the time, then each and every times, then we need to send the data. So if it's collide with this one, then it's needed to send back for the retransmissions. Okay, these are the thing in this pure aloha and slotted aloha. The maximum channel utilizations is only 0.37 with slotted aloha. The maximum channel utilizations is only 3.7 with the slotted aloha. The reason for this poor performance is that both aloha and slotted aloha fail to take advantage of one of the key properties of the packet radio network, which is that the propagations delay between stations in insufficient compared to packet transmission times. So the utilization is very insufficient in this slotted aloha, also in this pure aloha. So to overcome those things, then nowadays we are having different types of protocols. This is the how to say, the old technology used in this radio packet protocols. Let's move on to the carrier sense multiple access protocol. Carrier sense means we have to monitor the channel. Okay, we have to monitor the communication channel. This is one of the technique to reduce the collisions during time of the communications. Okay, CSMA. Okay, is a network protocol for carrier transmissions that operates in the medium access media access control or medium access control MAC layer. It sends or listens whether the shared channel for transmission is busy or not, and transmit if the channel is not busy. Using CSMA channel, more than one user or node send and receive data through a shared medium. That may be a single cable or optical fiber connecting multiple nodes, or a portion of the wireless spectrum. So in this wireless spectrums, if we are trying to communicate to other destinations, to other device, then we are using a single medium, then we have to sense. This is called carrier sense multiple access. Let's see here one more example. CSMA. So in each and every transmissions in the CSMA, it sends the transmission channel. Okay, there is no graphics representations, only the chart. Only the flow chart is there. Okay, here there are some vulnerable timed is equal to propagation times, that we have to sense the communication channels. If it's active in the media, communication media, then we have to wait it instead of colliding with each other. So we have to sense the media for multiple access. So if the channel is busy, then we have to wait it. If the channel is not busy, then we have to transmit it for multiple access without collisions. But also always sensing, and if this is busy, the communication channels, and it's delayed the transmissions, there are some limitations in this also. CSMA, carrier sense multiple access protocol. Okay, and more than one users or not send and receive through data through a shared medium. That may be a single cable or optical fiber cable or any other media or wireless spectrum. So we have to maintain the collision detections. Okay, so how to detect the collisions, how to maintain from the collisions. interceptions with the other transmissions, then we need to have this carrier sense multiple access protocol. Let's see here the working principle of the CSMA. When a station has a frame to transmit, it attempts to detect presence of the carrier sense from the other node connected to the set channel. If a carrier signal is detected, it implies that a transmission is in progress. The stations wait till the ongoing transmission executed to completions and then initiate its own transmissions. Generally, transmissions by the node are received by all other nodes connected to the channel. Since the node detect for a transmission before sending their own frame, collisions of the frame is reduced. However, if two nodes detect an idle channel at the same time, they have simultaneously initiated transmissions. This could cause the frame to gradually result in a collision. So that's one more chance of collisions in this CSMA. If the channel is idle, then if two stations detect these free channels, then it's try to send this data in the same time at the same times, then its collisions occur again. Okay, so these are the disadvantages and advantages of the multiple access in the CSMA. Okay, we're done up to this point. Next class we'll do this reservation protocol. Okay, that's all for